So hello, this is my QUAN assignment video. So firstly, I had to calculate the median for mean pressure. So I did this by using equal median and finding the column. So B2 to B366, I equal median the whole thing, and that's it. So for mean of dew point, I had to use equal average and find the column for dew point, which was column F, and did the same thing, equal average F2 to F366, the whole column, the data of the whole column. So after that, to find the average daily rainfall amount for each month, I had to use equal average, and I had to find the rainfall amount column, which was in column J. So now that I know the column, I use the first number here and calculate. So for example, January it's from J2 to J32, and for February it's from J33 all the way down to J60. So I did this for everything, for all the months. And to generate the bar chart, I highlighted the whole thing, went to insert, and bar chart, I chose the 3D bar and titled the bar chart average daily rainfall amount. So for part C, I did the same thing, equal average, just that I had to find the column for mean temperature, which was column E. So I did the same thing, equal average for everything, but except that it's changed from J to E. So I did it for the 12 months and generated the bar chart using the same thing, the 3D bar, except that I titled it average daily mean temperature. So for part D, from April to July, the average daily rainfall amount and average daily mean temperature was increasing for both these charts. So both are increasing, and for April, the data recorded was closer to a whole number compared to others. So this has only 2 decimal places, this one only has 1 decimal place. So this shows that the data recorded was more consistent. And during the start of the year, so for January and February, their data was one of the lowest compared to other months. Both data for the average daily mean temperature and rainfall amount. So to calculate the 95% confidence interval, the sample size for 365 1 year, mean was to equal average and find the column for max temperature. So equal average the whole column, and that becomes the mean. So for standard deviation, I use equal st.dev.s because it's sample, and for the whole thing also C2 to C366. So for Z alpha over 2, it equal norms.s.inv because it's a sample.s. So since this is a two-tailed S, 95 plus the 0.5% divided by 2 on both sides. So one side will be 0.225, and add them up is 0.975. So for the upper bound, I use the mean plus Z alpha over 2 times the standard deviation over square root 365, which is the sample size. And for lower bound, I did the same thing, except I use mean minus everything instead of plus. So for the next part F, the null was more than or equal to 31.7, the null hypothesis, since the question said the claim was at least 31.7. So the alternative hypothesis will be less than 31.7. To calculate the critical value, I use equal minus norm.s.inv, since this is a one-tailed the left tilt test, it should be negative, so equal minus norm dot sample, same thing. So I use 100% minus 5%, which it gives me 95%, so 0.95. So it gave me the critical value of minus 1.644. Test statistics, I use mean, the mean over here, minus the claim of 31.7, and the whole thing divided by standard deviation over square root sample size, which is 2.571. So since the test statistics 2.571 is more than minus 1.64 of the critical value, it does not lie in the rejection region. Therefore, we do not have sufficient evidence to reject the null hypothesis at 5% level significance. So the findings in E and F do not agree with each other, as the lower bound in E is more than the claim of 31.7. So that's it.